Hello and welcome to my video, lesson 1.2 on the arithmetic series. So just a reminder, we've had two videos before this where basically we talked about what a series and a sequence is. Then we looked at 1.1, which was the sequences and specifically arithmetic sequences, which is basically a set of terms. So it's a set of terms like with commas between them. And all that's happening between terms is there's some sort of addition or subtraction between terms. Okay, so what we were able to do is we were able to say, well, as a general statement, there is eventually going to be a tn term, an nth term, and we can generalize that nth term as this here, which is tn equals t1, which is our first term, plus n, which is whatever the nth term is, whatever number it is, minus 1 times d, which is the difference, or whatever we're adding or subtracting. All right, so Carl Gauss was asked by his teacher to sum the sequence. So he was asked to sum the sequence 1 plus 2 plus 3 plus 4 plus 5 all the way to 100. And he's like, hey, I don't want to do that. That's going to take a lot of time and a lot of work. So what he said was, hey, what if instead I make it a little bit easier for myself and I sum the, I first of all look at just the first part of it, okay? And I sum two sequences. So SN1, right, and SN2, and what if I add them together? And I think about it as 6 plus 5, the second sequence, as kind of the inverse, I suppose. So 6 plus 5 plus 4 plus 3 plus 2 plus 1. Instead of increasing, I decrease. Well, what's going to happen here is if I add those two sequences together, or series together, then what I get is that every term, so 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7, 4 plus 3 is 7, 5 plus 2 is 7, 6 plus 1 is 7. So every single one of these terms will actually add up to 7. And how many 7s are there? Well, there are 6 7s. So if we make that more general, we can say that 6 times 7. But how can we make it even more general than that? Okay, well, what we can say is that our nth term, okay, so our tnth term plus our t1 term, okay, that's like comparing this part here, times by the number of terms that there have been, okay, and then this is actually not going to be our final answer because we have two sequences here. Just keep that in mind. We actually have to divide by 2. So we divide by 2. All right. So this is pretty fantastic because we can now make it a little bit more general and go like this, tn plus t1. But we can even make it more general because we already know tn we can simplify to t1 plus n minus 1 times d. And we have t1 over here already. So we can put those two t1s together. So now finally our most simple version is 2t1 plus n minus 1 times d. All right, so we now have a fantastic solution for our summing of any set, or any series, any sequence of numbers. If we're summing all of them, it gives us a series. So if we want to find the sum of a series, this is how we can do that as a general form. So n over 2 t1 plus n minus 1 d. All right, so Carl Gauss came up with this, and so now we can actually get a lot of work done with this. So we're going to try to sum a couple series. Our first one is going to be 3 plus 5 plus 7 plus 9, so every kind of odd number, all the way to plus, I missed a plus there, all the way to plus 31. All right, I've just picked one at random here. Now, it depends on the version that you have. We kind of need to figure out what number that term is, right? So we do have Tn in this case. Let's just show that. We do have Tn. This is Tn. So from our formula, or actually, we have two different formulas, right? We also have this formula, Tn plus T1. From this formula, we can actually say we have Tn. We also have T1, right? So that's good. What we don't have is we don't have n. So we need to solve for n first. So how are we going to do that? Well, we can use our original over here from last topic to solve for Tn. Or to solve for n, sorry. So what we can do now is put in what we know. So 31, 3 plus n, we don't know n. But we do know d is plus 2, so let's just put a 2 in here. Okay, now what we can do is get 3 plus 2n minus 2, have 31 over here. We can get 2n plus 1. We can get 30 equals 2n. And so now we can say 15 is our nth value. Okay, hopefully this is not going to be too big of a number. I don't think it will be. I don't think it'll be too bad. All right, so now that we have that n, now we can plug it into this equation. So Sn equals, and we can actually say S15 equals 15 over 2. Tn is 31, plus T1 is 3. So now let's try simplifying that. So 15 times 34 over 2. 34 divided by 2 is 17. So 15 times 17, oh gosh, let me just plug that in. 15 times 17, 255. So the sum of this series is 255. Okay, and oftentimes it'll already tell you the n value, and so it won't be quite so difficult, but that is a possibility where it doesn't tell you. Okay, and here let's make another example question. Let's maybe make it bigger gaps between. So 2 plus 7 plus 12 plus ... plus some nth term, but I'm going to say that I know exactly what value of n this is, so I'm going to say 23. Let me just make that a subscript 23. There you go. So this is another question. So 2 plus 7 plus 12 plus some value all the way up to 23. So what are we going to do with this? Well, we're going to use our formula again. So let's try to use this, the blue formula, whoops, from right over here. Okay, let's try to use that. So I'm going to use blue to hopefully remind us. Oh, there you go. Okay, so what we need to do is S23 equals, well, we already know 23 is our n. Okay, we also know our T1 is 2. We also know our n term is 23. We still know that, I suppose. And we know the difference between each term is 5, adding 5. Okay, and so now we can either plug all this stuff into our calculator all at once, which I want to show you guys how beautiful this can be if you have a good calculator and if you're used to using it. You can literally plug it all in, and it's a wonderful thing. Or you'd have to break it down every step of the way. All right. So I hope this video helps you understand arithmetic series a little bit better. Good luck.